Hi. Welcome, everybody, to the 4th Annual Community Engaged Research Lecture at UNM. It's an event sponsored by the Office of the Vice Provost for Research. I especially want to thank Vice President for Research, Gabriel Lopez, in front here, and also the Director of Community Engagement in the front, Dr. Monica Kowal, for the great work behind all of this, both by the VPR and by his whole staff. My name is Rich Wood. I'm a professor of sociology here, serving as the interim provost this year, and I am painfully aware that no one's here to hear the provost speak, much less the interim provost speak, so I'm going to try to be very brief. I am born and raised in New Mexico, deeply attached to the state, and also in my own research, I build on a certain tradition of community engaged research, so the topic tonight is very dear to my own heart. It's great to be here with you all. It's an opportunity for UNM to demonstrate to the wider world and to our own folks how much we do engage this kind of community engaged work. It's one of the important kinds of research that happens at this university. And it captures the sort of, Dave Gutzler's work in particular, captures the sort of academically relevant work, often peer-reviewed work, that also has this deep impact, a meaningful impact in communities and settings in people's lives. And that's a kind of gold standard for what a research university ought to be about. And Dave exemplifies that. And the award honors really exceptional scholarly work. And we celebrate Dave Gutzler's achievements in his work as a professor of Earth and Planetary Sciences. And tonight we'll get a glimpse of his work. In a 45-minute lecture, we won't get a full view of everything he does, but we'll get a glimpse of his work, and then he'll be presented with this year's award. So tonight we celebrate Dave Gutzler through his lecture on the science and politics of climate change, Tales of a Turbulent System. Peter, would you please come and introduce Professor Gutzler? Thank you all.
Should leave it at the same place.
Maybe that'll work.
That'll work. Thanks, Rich. All right. Thanks, Rich. My name's Peter Fawcett. I'm the chair and a professor in Earth and Planetary Sciences, and it's a great pleasure to see you all here tonight to celebrate the accomplishments of my colleague, Dave Gutzler, winning the Community Engaged Research Lecture Award this year. A few words about Dave. They gave me 10 minutes, Dave, so I'm gonna just spend a little time getting warmed up here. Dave hails originally from San Diego, and one time he was a surfer dude, and he stayed in California for his bachelor's. He did a bachelor's of engineering physics at Berkeley, went up the coast to Washington, where he did a Master of Science in Atmospheric Science, and then flew across the country to the other coast, where he did a PhD in meteorology at the Massachusetts Institute of Technology. Following his PhD, he spent several years working in private industry, and then moved out to Boulder, where he was working in the NOAA federal laboratory there, and then came down to New Mexico with his spouse, Jane Silverstone, in 1995, where he's been ever since. Getting a little bit of feedback, so maybe I'll step away from this a bit. Now, he has a number of impressive degrees from impressive institutions, but I have to tell you that I learned that he has never taught a class here at UNM that he actually took at one of those prestigious institutions. And I thought, well, so much for vetting faculty, teaching qualifications, right? In fact, Dave is an exceptional teacher, as many students will tell you. Over the years, he's mentored many undergraduate student theses, he's mentored graduate students, and of course, his classes in climate dynamics, and global climate change have attracted a wide following. Many of the students are probably here in the audience tonight. So broadly speaking, Dave is a climate scientist. And what does that mean? Well, it spans many different aspects of the atmosphere. Dave's looked at things like El Nino, atmospheric teleconnections, atmospheric circulation. Since he came to New Mexico, he's taken a particular interest in the North American monsoon and looking at things like drought and the effect of vegetation, future climate change in the state. He's an accomplished researcher. That's one of the qualifications for this award, is that you actually have to be a very strong researcher, and Dave is certainly that. He's published many important articles on different aspects of climate science, and many of those, by the way, are with his students, which is really impressive as well. He's an accomplished teacher, as I just noted. But what is it about Dave's work that rises to the level of community-engaged research? And I would argue that it's the extent of his work and engagement with so many different communities across the state, the country, and in fact around the world that lead us to this honor. His work touches on the climate forecast community. The question, how much is it going to rain this summer? Dave gets asked that a lot. He doesn't like to answer it, but he has addressed that sort of thing in his work. Water use, water planning. His work's been used by ecologists, water policy professionals. He's organized and participated in workshops and public meetings and lectures. And he's frequently called on by the press to explain climate topics that are of interest to the state of New Mexico. And in fact, he's consulted on these same topics by state legislators and other decision makers. Perhaps most notably, Dave was a lead author in the 2013 IPCC report, which convincingly demonstrated that there is human influence on the climate change system. This report was the main source of scientific information that underlay the 2015 Paris Accord on climate adaptation and mitigation. This was signed by 194 countries in 2015. There was one significant withdrawal in 2017 because fake news. And Dave was the lead author on the chapter discussing detection and attribution of climate change. In other words, who done it, and that was highly influential in the impact this report had on the global community. I would also note that Dave has the honor of being selected as a lead author for the 6th IPCC report, which will be published in 2021, which is a great honor for Dave, and it's a great honor for this institution to have someone of that repute to get that authorship. His chapter is going to be on North American impacts, adaptation, and vulnerability to climate change, and this is going to be critical for planning and future adaptation. You only have to turn on the TV and watch the evening news to see how important that topic is, right? So finally, in the nomination packet, I had the help of 3 external reviewers, and I just wanted to say thank you to those folks tonight for helping write strong letters of support that helped Dave to get this award. Mr. Kerry Jones, who was a former student of the Water Resources Program here, and he's just been promoted to the director of the National Weather Service office here in Albuquerque. Mr. John Fleck, who is the current director of the Water Resources Program and was a longtime science writer for the Albuquerque Journal, one of those people, hey Dave, what about this? And Dr. Nelia Dunbar, who is the director of the New Mexico Bureau of Geology and Mineral Resources and the first female state geologist for the state of New Mexico since statehood. And those 3 wrote excellent letters, and it was really outstanding. There's one term that one of those letter writers used to describe Dave and his community-engaged research, which is really appropriate because we're kind of an Earth and Planetary Sciences department, and that term is type section. You know, you have something that you refer everything else to that is the best example of it. And that letter writer said, Dave is the type section of a community-engaged scientist. And so with that, Dave Gutzler.
Well, thank you, Peter and Rich. I'm humbled. I give a lot of talks. I've never given one quite like this, and I'm just truly humbled to have so many friends and colleagues here, and I thank you all for spending some time here. We'll talk about climate change for a few minutes. And most of you probably realize that my title is a lame attempt at a bit of a pun. The reason climate change is such a wonderful academic topic is that it is a gloriously complex, turbulent system that is nevertheless, to a limited extent, predictable. And our scientific challenge is to understand the system well enough in order to make those predictions in a way that's useful for people. When I started out, that's all climate change was, a really cool puzzle that attracted the attention of some scientists. When I was a grad student, there was little indication that it would be a topic that would get caught up in political turbulence, but there we are. And so in addition to having, wonderful systems of coupled differential equations that we like to manipulate and try to understand, global warming is encapsulated by the H dot term right there, as many of you undoubtedly recognize. We also have very intelligent but non-scientific authors like Michael Crichton writing utterly nonsensical potboilers, declaring that the whole thing is a hoax, and then writing about it in this scientific publication, Parade Magazine, telling people that they shouldn't get very scared about this. And so we have an interesting interaction here between a bunch of dweebs that really are attracted to systems of equations like this applied to gridded spheres, and a bunch of political policy people trying to figure out what we ought to do about it. So we better talk about science first. Here's global warming. This is the instrumental record of global temperatures going back to the late 1800s. And if we just stare at it, most people might agree that it's actually getting warmer. And you hear about this early every year when this curve gets updated, usually around the end of January when we add one more year. There is the most recent update for the month of September. We don't have October yet. The red squares indicate parts of the planet that in the month of September were above average in temperature compared to a long-term, typically 20th century baseline. And it's warm almost everywhere, almost every month compared to some average, and so we call it global warming. There's a lot of problems with every single data set we use, and so when we talk about trying to establish what's going on scientifically, it is very important for us to have redundant data sets, duplicate data sets, and it's really critical that in addition to just having a gridded product based on temperature measurements, that we have all kinds of independent verification that the climate's warming up, and so we have all sorts of proxies, the glacier volume, the level of the ocean, the level of sea, or the extent of sea ice. They're all pointed in the direction of warming temperatures. So the evidence is there, and we write these fancy IPCC reports. As Peter mentioned, I was an author on that one. And every 7 years or so, we publish a new one and say pretty much the same thing that the previous one said, which is it's still getting warmer. And we know why, right? So here is the record of the entire record of directly measured atmospheric CO2 taken at the top of Mauna Loa, which was started in the International Geophysical Year in the late 1950s. And so there's a dot here for every month. There's a little annual cycle, up and down we go every year. That's the planet breathing due to the seasonal cycle associated with photosynthesis, which is largely a northern hemisphere signal because that's where the land plants are. But then in addition, we have this relentless march upward. So that in the late 50s, when this record was started, we had a CO2 concentration of a little over 300 parts per million. That's not an awful lot, but it's enough to keep the planet warm because we know what CO2 does to the surface temperature. It absorbs radiation that otherwise would leave the planet and recycles it back to the Earth so that the greenhouse effect keeps the planet warmer than it would be otherwise. Very basic, fundamental physics 101 stuff. Up goes CO2, and all else being equal, the planet has no choice but to warm up because the energy recycling near the surface is increasing as we increase the amount of CO2. By the way, I take surveys about knowledge of how this works. And when I first started doing it, I surveyed my Earth and Planetary Sciences faculty colleagues, and 2 of them didn't get the right answer. and I got the same percentage of answers that weren't quite right when I surveyed a random sample of non-Earth scientists. The difference was that the people that were wrong, who were the non-Earth sciences, ticked the box that said, I don't know, whereas none of my Earth science faculty colleagues would dare tick that box. They just gave me the wrong answer. All right. We can tack that instrumental record, which is pretty short, onto much longer records from old air taken out of bubbles of ice in ice cores, and we find this famous plot in which the curve that's now covered up is this part of the curve, and we attach onto it the record from ice cores, and what we see is that for almost 10,000 years, going almost back to the last ice age, the CO2 concentration of the atmosphere was pretty steady. We can have a nice debate over that little uptick very slowly with time over several thousand years. But then the Industrial Revolution happened, and that's what we're doing since then, right? So there is no doubt, and I won't go into the evidence for it, but there's no doubt we know where this extra CO2 is coming from. It's coming from you and the rest of us burning fossil fuels predominantly, but also changing land use cover over the planet. This really is due to the activities of people. Okay, so we know the temperature is going up. We know that greenhouse gases are increasing in their atmospheric concentration. And so there's a very circumstantial case to be made that humans are changing the climate. We use climate models then to try to firmly establish cause and effect, because just based on data, it's very difficult to make a definitive cause and effect case. But with the kind of models based on the differential equations I showed you in the first slide, we can play games like this, right? We can do controlled experiments with models that we cannot do with the real climate system, thank goodness. And so our goal here is to try to reproduce that black curve right there, which is simply a smooth version of the global warming curve I've already shown you. And with climate models, we find that if we feed the model the observed increase in greenhouse gases, and we do this with many models run many times, we get this envelope of temperature shown in pink. So the claim is that if these models are actually representing the climate system reasonably faithfully, we seem to be getting more or less the right answer for 20th century global warming if we put in all the greenhouse gases. If we take the greenhouse gases out, that is to say we just leave CO2 at its 1900 level and run it without increasing greenhouse gases, then we get this blue curve, and we fail to reproduce, in particular, the part of that curve where it's really warming up in the late 20th century. So the conclusion we reach is that we get the right answer with models that we think ought to do a good job if and only if human forcing, that should be students, included. And to get the right answer, we have to put in what the humans are doing to the climate, both adding greenhouse gases by burning fossil fuels and adding air pollution and particulates that actually cool the climate. And in a different lecture, we'd spend a whole hour doing that, just convincing you of that. And in the most recent IPCC report, we went beyond doing this for the global average, and we can play the same game with models to try to reproduce observed temperature changes on a continental scale, or to reproduce ocean heat content in the North Pacific, et cetera, et cetera. And over again, we reach this conclusion that we get the right answer using models only if we put in the human forcing. And that's the reason we blame humans for observed 20th century global warming. If you buy that, and we do, then we can take the same models and we can run them forward in time to project what might happen in a future climate under some assumptions of how much greenhouse gas we add to the atmosphere moving forward in time, and we make maps that kind of look like this. Now, we don't know how much the greenhouse gases are going to be increased. That depends on policy decisions. So we can run the model with a low emissions scenario where we assume that we take very aggressive means to mitigate and lower greenhouse gas emissions, or we can run the models again under a high emissions sort of business as usual scenario in which greenhouse gases increase rapidly. They all warm up. That's what these yellow and orange colors are, and they warm up a lot. The continents warm up more than the oceans, and we understand why that is. The poles warm up more than the tropics. We can explain that too, and I'm glossing over lots of the details. And the rate of temperature increase depends on whether we add lots of greenhouse gases or not so many greenhouse gases. So if our goal is to try to limit how much the planet continues to warm up, these model projections suggest that we have a direct incentive to mitigate emissions and try to follow the low emissions path rather than the high emissions path. Precipitation is a little bit trickier. It depends not just on the direct input of energy into the system, but on the changes in winds and humidity that are based on that energy input change. But this pattern of precipitation follows what's often called a wet gets wetter and dry gets drier scenario, in which the wet parts of the planet are shown here in blue, and they tend to get even more precipitation in a warmer climate, whereas these belts in the subtropics, where most of the world's deserts are, get even drier.
Quick question, if I may.
You may.
The real red part there looks like it might be a lot hotter. How much hotter is that?
What a great question. Let's just do that and blow up part of the... So the rest of you shills, keep up the good work. No, I just So if we just take these squares and blow them up, then what we see is that under this high emissions scenario, the middle of the continent, kind of where we are, is warming up at a rate of 4 or 5 degrees Celsius per century. Right? That is a huge climate change. That is enormous. And we'll talk about that in a minute. And here we are. Precipitation is a lot trickier because it gets wetter toward the Arctic, that's the blue colors, and much drier down here in the tropics. And we're right pretty close to this region of transition between orange, that's less precipitation, and green and blue, that's more precipitation. So the precipitation projections for this part of the world are pretty uncertain compared to the temperature projections where we just say, book it, it's going to get warmer. And really the only question is how much warmer and how quickly. And everything's subject to large quantitative uncertainty, because remember, I don't know which of these scenarios we're going to follow. And what's buried in here is a fair amount of model-to-model uncertainty. These maps are based on the average of a large number of climate models, and they all behave a little bit differently. I first started learning about this almost 20 years ago. I really didn't come here with much expertise or experience thinking about these long-term climate change issues, but I got hired by the gas company, which at that time was PNM, to analyze heating degree days as part of a gas rate hearing. And so we looked at the heating degree days since about 1950 across the state of New Mexico. Now, heating degree days are how the utility company determines what the climatic heating demand is going to be. We won't go into the details of how you calculate that, but it's a way to kind of integrate temperature over the whole cold season. And when you have many more cold days, then you get many more heating degree days. So lots of heating degree days means colder climate, and fewer heating degree days means a warmer climate. And so I pulled this out of my filing cabinet. I hadn't looked at it for quite a while. I did this quite a while ago. And you can see that even by the turn of the century, the number of heating degree days in Albuquerque during the period of time where things have warmed up is down by about 15% since the middle of, since about 1960 or so. And there's an even clearer trend at this glorious weather station outside Silver City that doesn't exist anymore. Down we go. That's a very strong warming trend, and this matters because it affects your utility bill, right? So if the gas company is going to sell less gas because it's warmer, guess what happens to your rates? How many people think that's a good idea? So anyway, we already have a really significant societal impact. This is worth a lot of money in utility rate hearings already. And since that time, it's just gotten warmer. So here's a graph of temperature and precipitation across New Mexico that we first developed a few years ago as part of a working group that I was involved in, making a water supply vulnerability report to the state legislature. This is statewide average across New Mexico, and there is our temperature trace since 1960 or so, and up it goes. And so if you just squint at the plot, what you see is a temperature increase of about 3 degrees Fahrenheit between late 60s or so and the present. And so the previous graph went up through about here, and just up we go. There's plenty of interannual variability that's just due to the winds shifting and all kinds of natural variability, but there's just an unmistakable trend going on. And in fact, if we think about the climate trend implied by those maps from models that I just showed you, the trend here is very similar in magnitude. So what we're seeing here over the past 40 or 50 years is what we interpret as the start of an increase in temperature at a rate of 4 degrees C, 7 degrees Fahrenheit per century. So there's nothing hypothetical about global warming expressed locally. We see it in the data, and really what the models are doing in terms of temperature is just telling us that we ought to expect some continuation of what we've already seen over the past few decades, extending out into the future, and dependent on the rate at which we continue to load the atmosphere with greenhouse gases. Notice that there is no obvious trend in precipitation. There's a lot of decadal variability. We had a big drought in the 50s. We had some wet decades after that, kind of droughty years since then, but not a real clear trend in precipitation. Also not too different from the kind of uncertainty that we see in those climate model projections. That has some big effects. So what happens when you warm up the temperature? One of the big effects here that we've studied a lot over the past few years is its effect on water resources in New Mexico. And so here is a graph that my former student Shailene Chavarria, who's sitting here someplace, put together a couple of years ago, going back to the late 1950s, looking at snowpack in the headwaters of the Rio Grande, which is a snow-fed river. And we have lots and lots of interannual variability. Up and down we go, depending on precipitation varying from year to year. But superimposed on the variability is a downward trend. If you just draw a straight line through there, you get about a 25% decrease since the late 50s overall in terms of snowpack, and that's a temperature effect. That matters a lot, and in fact, this is something else that comes out of climate models. If we make a projection in climate models of what we can expect in terms of snowpack, all those bloody red colors indicate 25, 50, 100% decrease in snowpack centered around the margins of the snowpack where it's warm. And so we are here in the banana belt for snow, and the effect of the kinds of temperature trends that we see in the data and that are projected to increase in the future will just be to decimate the snowpack. And we're already seeing it happening in the headwaters of the Rio Grande. The diminished snowpack also melts earlier in the year. That sets up a very interesting situation in which the springtime dry season here gets even drier and warmer, and that helps dry out the planet and contributes to a very robust projection in climate models that the entire Southwest will just become more arid as a result of the climate changes that we're already seeing and that are projected to continue in the future. Dean Coonrod here at UNM. Would you like to come explain this plot? Put a few of these climate change projections into actually a rather primitive water balance model, and I don't mean that as an insult at all, to ask what's the effect of what we just looked at in terms of runoff, snow melt runoff in the Rio Grande in the middle Rio Grande. And so this is the hydrograph that she came up with. So we're looking at average flow in the middle Rio Grande starting in October through the winter dry season. Here is the snowmelt runoff peak in May and peaking and then moving back down to lower flows as we move into late summer. And so if you put those climate change projections into this water balance model, what you find is that in the near term, the snowmelt runoff peak gets a little bit weaker and we start losing flow in the dry season in late spring. That's that lengthier and warmer dry season, diminishing flows. And then by the time we get to the end of the 21st century, we have a very sharp decrease in the snowmelt runoff and a peak that's moved earlier in the year, and with the rather frightening result that you could expect on the order of 20 or 25% decrease in total runoff, which is just the area under the curve. The total amount of water going down the Rio Grande is projected to diminish by 20-25% over on average as a result of mostly the warmer temperatures and diminished snow in this model. Now, we are revisiting this kind of projection. Nels Bjarke is taking a look at this to ask really how much should we expect the runoff to be reduced if we try to investigate much more complicated models. And so there's a lot of science still to be done to work out the different effects of projected precipitation and projected temperature on runoff in the Rio Grande. And I bring all this up mostly just to make 2 points. One is that we should care about this in terms of water resources for New Mexico. And number two, there's a lot of really good science still to be done, questions that still need to be answered. I'm not out of business, right? So, and this is the stuff I'm trained to do as opposed to what we're about to talk about for the second half of the talk. Okay, so the bottom line here, we're really good at making fancy graphs and thinking about wonky climate concepts and writing lots of words. So if we look at the latest IPCC report, we say that the warming of the climate system is unequivocal, which is a word you almost never hear scientists utter, with lots of complementary evidence to essentially prove that that's happening. All right? And so we just beat this into the ground because there are still people out there that want to say it's all a big hoax. Unfortunately, one of them sits in the White House. But there is no debate at this point within the scientific community about the reality of global warming. It's happening. I was one of the people that helped write that sentence here, and we spent just a ridiculous number of hours parsing the wording. That's what we do at IPCC meetings. And we say that it is extremely likely that human activities caused more than half of the observed increase in global mean temperature in the late 20th century. And if you remember what that curve looked like, there was a lot of warming in the late 20th century. And I would add that the projected 21st century changes and impacts are potentially profound but difficult to quantify. And that's where we stand in terms of the science. Okay, so if this didn't have policy implications, we would have a wonderful time working out the uncertainties. We would argue with each other, and we would find that some of the things we thought were right weren't quite right. We'd fix them all up. That's how the scientific method works. But it's not all that easy, and we aren't working in a vacuum. And when I think about words like that, one of the things we learned very quickly is that your eyes are already glazing over, so would the public's eyes. And so we try to come up with examples for what those words really mean. And so here's one of them. This is a climate change scenario we cooked up almost a decade ago. This was Tesha Robbins was a student of mine who did this for her senior thesis. And so here is the kind of projection we've looked at. This is a projection based on a bunch of models averaged together for temperature in central New Mexico. So one evening I sat at home and I wondered, where can I go? Where do I have to go if this is what the climate of central New Mexico is going to look like in the year 2100, where can I go now to see a climate that looks like that projection? How far downriver, how far south do I have to go? And the answer basically is El Paso. So what this temperature trace translates to is that the temperature, and in fact the precipitation too, associated with that projection makes central New Mexico have the same climate that El Paso essentially has today. Okay, so there's mountains right outside El Paso. That's what they look like. They're excellent hiking. I work with people down in El Paso. People enjoy living there. We do not make the claim that the world will end and we'll all die as a result of that much warming, but it will be a very different world. Okay, so if this is what the mountains of around El Paso look like, and that's where we're headed, notice the forests. There aren't any, right? The mountains around El Paso basically don't have any trees. So that's the kind of vegetation that's supported by the climate of El Paso, and that's where we're headed. So I don't think those trees that we see up in the Sandias are going to be here in 2100 if this sort of projection comes to pass. So what will happen to the trees? They won't just disintegrate. If you want to know what's going to happen to the trees, ask people that live in the Jemez Mountains, where they've had some pretty big fires, or ask people in California right now, right? That's our future. That's where those trees are headed. They're going to burn. And it won't be calm and gentle and gradual. That's how we're going to transition from the current vegetation we see in the mountains to the vegetation associated with 2100 in this climate change projection. So when Michael Crichton tells us that we need to stop scaring ourselves, this scares me. It really scares me, and I think it ought to scare you. This is not a subtle kind of climate change. It's not anything small or gradual that we're talking about. We're talking about over the next half century or so, really converting to a different climate with pretty dramatic consequences for the environment in which we live. So, what are we supposed to do? Enough wonkish stuff, right? So, what are we supposed to do? This is the stuff I have no training in, but that I engage in all the time, right? So, what should we do? I'm going to split this up into two parts. First, what should I do, where we is me and my peers as academic climate scientists? What am I supposed to do about this kind of information? Well, we need to do solid science, right? So I feel no shame in retreating back to my office to go calculate something because that's what I'm supposed to be doing. We should fearlessly share what we know. Fearlessly is a very odd adverb to use as an academic scientist. And I have to say, I've not been personally threatened by anybody, but I know people who have. It's a very odd world that we live in, where the kind of information that we are acquiring via the usual academic means is cause for threats. That's bizarre. We need to be open, honest, and humble about the uncertainties in our knowledge. Everything I'm saying here is true for all of you on the faculty. That's what we should be doing. It can be a little bit trickier here than it is for people in some other disciplines, but it's just true in general. In my business, we have kind of an organized means for sharing what we know. We write these big tomes. That's the IPCC report that I was a modest part of up at the top. There's a climate science report done within the US that came out just earlier this year. And so we keep producing all these reports that are intended to tell policymakers what we know with uncertainty so that they can act on it. This guy is one of my heroes. That's Dan Albritton. He's not a really famous scientist, but he was the director of the NOAA Aeronomy Lab. One of the reasons he's one of my heroes is that he hired me, which was kind of a heroic thing to do. But he pounded into the people in his lab the importance of doing all of this. He did not allow his scientists to sit in their office and just have fun and calculate stuff. He wanted his people to participate in efforts like this, and Dan was an integral part, kind of behind the scenes, of many of these IPCC reports, and he influenced the way I think about community engagement in a real fundamental way early in my career, and I'm grateful for that. But I'm not sure everybody reads the 1,500-page IPCC report, so this probably isn't enough to share what we know with policymakers and the public. So among the things I do is I give talks to the public. I've actually given quite a few of them at venues across the state that I put a little slideshow together of. And so we spend a fair amount of time on this. It is one of the things I find worthwhile about my job. I've had a marvelous time interacting with the public, giving these talks. The people I've interacted with are almost all really polite. I've been heckled a fair amount, but much less so in recent years. So I get a lot out of these talks. I've even learned from the hecklers and naysayers, but my pitch to my colleagues on the faculty is that this is very cool stuff and that the public really wants to hear what we're doing, right? I do worry that what people think of the University of New Mexico is that we have a hospital and a bad football team and not much else. And there's so much more to what we do. People are really interested, and we need to be out there sharing what we do with the public. Do they believe anything I say? I think they do. Okay, so here's a very difficult plot to look at. It's a paper in which these academics tried to gauge whether, which fields, which professions people viewed as filled with people who were competent and people that they could trust, which they called warmth. So the question is, what professions generate trust and respect from the public? And the good news is there we are, right? What professors are, you want to be up in the upper right-hand corner here. And professors rate that. And I can tell you from my own interaction with the public, people respect professors. Much more so than you might think from reading the mainstream literature, where it's fun for pundits to make fun of pointy-headed weirdos. But when I go out in the public, the fact that I'm a professor at UNM matters, and I benefit from that. Lawyers, like my friend Paul, if you're a lawyer or a politician, on the other hand, you're kind of down with in between garbage collectors and prostitutes in terms of trust. This study actually, one of the things they did was they specifically asked people about climate scientists. And do you trust climate scientists? What are the sources of distrust? And they gave people a bunch of options here. Lie with statistics. I see some people that have taken my statistics class. There was only one aspect of climate science that people said they really was a big source of distrust. And I guess not surprisingly to me, it was that we're just trying to get money, that there's a big reward in being an alarmist, because that's what people are told. It's a complete misunderstanding of the reward and motivation system for getting external research dollars. But Gabrielle, the message for me is that if I want to raise the level of trust among the public in me, then I need to stop writing grant proposals. Yeah. And then we think a lot about what the proper role for scientists is in public discussion. This is a very wonky political science jargony matrix of possible roles for scientists. So I value the trust that I have. I want people to think that I'm telling them what I've generated as a scientist, and not because I'm trying to convince them to pursue some policy that I happen to promote. So there's basically two columns here. The first question is, should a scientist engaging in a public policy debate stick to the science, or should I engage what we call normative questions, which have to do with value judgments? So the basic idea is that as a scientist, I have some credibility and knowledge that makes me an expert about climate, but that doesn't mean my judgments about what's important, what's worth paying for, etc., have any more standing than any of your opinions. So the first thing we do, and so we have two choices there. So I need to click that one. The first thing we do is cross off the role in the upper left. That's the pure scientist who never leaves their office and just says, I don't want to say anything at all about policy because I'm a scientist. I'm just going to go write more papers. And in my business, it's just not possible. There's just no way for me to totally ignore the fact that what I do has policy implications. The guy that wrote this book, Roger Pilkey, was promoting this role. That's the honest broker role in the other corner of this matrix. So the idea here is that I, as a scientist, would engage the policy community, and I would try to sort out policy objectives by saying, if you do A, this is likely to happen. If you do B, that is likely to happen, without passing judgment about which choice is best. So we say, what if? And here's what I think is the outcome if you take this policy option. I try to follow that. That's what my old boss, Dan Albritton, would have told me to do. I have to say that as the years have gone by, I make one exception to the non-prescriptive judgment. Tell me what policy you'd like to choose, and I will give you my best guidance as to the outcome of that. And that is that I am willing to narrow the policy choices like a science arbiter who tells people the science tells us that the best policy is X. That's not being even-handed about policy. And I try to be even-handed policy with one exception. I now think that the science tells us that it is an unacceptable choice to do nothing. But beyond that, I'm happy to try to be as the best honest broker as I can. Interestingly, when I present this matrix and we discuss it in class with students, what they want me to do is to be an issue advocate. So the students tell me, despite my best efforts to dissuade them, that I know what's going on with the climate. They want me up there in Santa Fe and in Washington pushing for aggressive policy action, right? That's what an issue advocate would do. I would use my knowledge to really push for particular policy objectives, and students are big on that. Now, I'm not teaching a random sample of students. Most of the students that take my class are predisposed to be very worried about climate change, much more so than your average state legislator. But this is the sort of matrix and the sort of choices that we are confronted with in my business all the time. Okay, so now I'm going to ask, what should we do, trying to be an honest broker, where we is defined as you, the public, policymakers, people that aren't necessarily professional climate people. So there's two basic things we ought to consider, and one we have no choice about. Okay, so the climate is already changing. I hope I've convinced you of that. So we have no choice but to adapt to a changing climate. We have to do this. We don't have a choice. This is a picture of Elephant Butte Reservoir. It's empty. Okay, it basically was drained this year by irrigators downstream who owned the water that was left in Elephant Butte after years of drought. There's nothing left there. We better get used to it. So Nolan Townsend, one of my students, is looking at projections for Elephant Butte as part of a project to examine the resilience of irrigated agriculture downstream from Elephant Butte. And what we see generally is sort of a decrease in the flows. This is much like what Julie Coonrod's results looked like. And what we see is generally just lower flows going out into the future. So the prospects for filling up Elephant Butte are dicey. And it's not we cannot look to the past to guide us for what we might hope for in terms of filling up Elephant Butte as the years go by. That's an example of the kind of adaptation at this point that we have no choice but to make. The other component of what we should do is to at least consider, and I would say we better do it, mitigation. That is to say, we better start taking steps belatedly to reduce our greenhouse gas emissions to try to prevent the high emissions scenario from happening in favor of the lower emissions scenario where the climate change is less intense and happens less quickly. So step one is no more climate denial. That's stupid. At this point, the evidence that the climate is changing and is likely to continue to change is so overwhelming that simply denying that and doing nothing is just choosing stupidity. We can do better than that. There's a whole book here about the effort over the years to basically throw doubt on the reality of climate change with the sole purpose not of doing good science, but of simply delaying or stopping any kind of policy action that would mitigate emissions. Okay, we ought to think long-term about energy and the environment. We need to spread the benefits of clean energy and renewables across society, and we need to re-engage the international community. And let me say just a few words about each of those before we close up shop here. Thinking long-term has some pretty scary implications for New Mexico. So here are some scenarios for emissions put out in a report that just came out a very short time ago by the IPCC. And the idea here was to think about what sorts of emissions scenarios would be required to keep the climate change limited to 1.5 or 2 degrees. And what's required is to reduce our carbon dioxide emissions from about 40 gigatons a year down to 0 by mid-century. Okay, that's not very far away, and we are talking about the complete elimination and in fact going into net emissions territory where we're actually sucking CO2 out of the atmosphere at the end of the century. And let me point out that to do this, there's also a scenario for methane emissions, which we need to consider carefully in New Mexico. That's what comes out of natural gas. The scenarios that limit climate change involve rapid decreases in methane emissions, not necessarily going to 0 because we're moving away from the big CO2 emitters like coal to natural gas, which emits more methane, but still a large decrease over the next couple of decades. Now, these scenarios are considered aspirational, kind of pie in the sky, but something along these lines is going to happen because the global community will not tolerate the kinds of really severe climate changes that will happen in the absence of reductions like this. So how much, how fast, I'm not sure, but I think that here in New Mexico, if we don't recognize and get ahead of the curve in terms of reducing greenhouse gas emissions, we'll be left behind by the global economy. Right? I don't see any reason that following some sort of pathway like this is not technologically possible. We know how to do this as engineers. That's not the problem. The problem is, in implementing this, is political and socioeconomic. And here's what I think the real challenge is. As we move toward a renewable future, we're leaving behind whole communities that are dependent on fossil fuel production. So here is a story from the Albuquerque Journal talking about coal's decline in power production hitting the Navajo Nation, where they dig coal. We have an entire part of the United States in Appalachia that's feeling left behind because as we move away from coal, as we must do to mitigate climate change, we're leaving behind entire communities and impoverishing them, and they won't stand for it. And why should they? So as a society, I think we've done a great job in starting to develop the technology we need to move toward a clean energy future. We're miserably bad at sharing the benefits across society. So we end up with big winners and big losers. And that's got to change if we're going to get the buy-in we need across society to make this happen in a reasonable length of time. Maybe a good place to start would be if publications like The Economist, to which I subscribe, stopped portraying blue-collar workers as hapless losers in the stories they write about this topic. So we have a real problem, a real challenge in academia connecting with these parts of society, and we've got to develop ways to allow the benefits of a transition to renewable energy to be shared across society and not leave entire parts of our society behind. This is a big problem for the state of New Mexico, needless to say. Here are some headlines that talk about the fact that the state economy is on the upswing, and this university's budget is on the rise as the result of fossil fuel extraction. So here's some pointy head standing in front of you saying, well, we have to stop this, time to decrease emissions and transfer fuel usages really fast to prevent climate change when the state's economy depends on it. How are we going to deal with that? And the state of New Mexico better figure out how we're going to deal with that. And at this university, I would advocate we should be helping our community and our state figure out the strategies we need to avoid becoming the next Appalachia over the next few decades when our fossil fuel revenues start to go down as the inevitable transition to renewables takes place. None of this is new. We're paying for problems that we've known about for decades that we've ignored. So forgive me for reading this. Few people doubt that the world has entered an energy transition away from dependence upon fossil fuels and towards some mix of renewable resources that will not pose problems of CO2 accumulation. The question is, how do we get from here to there while preserving the health of our political, economic, and environmental support systems? That's sort of what I just said, but put more elegantly. Who wrote that? Maybe Al Gore. It was the president of Exxon Research. When was it written? Here's a clue. I bought that book when I was a grad student, all right? October 1982, and so for almost 40 years we've done almost nothing about this, and nobody can say that had the power to do something about it that, oh, we didn't know about this, this is all new news. It's crazy. We are now paying the price for ignoring what we've known was going to happen for decades. So we've chosen stupidity, and it's just time to get beyond that. The quote that seems apropos to me is from Will Rogers, right? If you find yourself in a hole, stop digging. So the thing to do is to actually get moving on the transition to renewables, but in a way that where everybody benefits. I don't know how to do that latter part. That is a huge challenge for us. Okay, finally, the domestic political challenge. You knew I couldn't give this talk without this. Almost 8 years ago, I was an expert witness at a hearing in Santa Fe, actually 2 hearings, when the state in the waning days, the waning months of the Richardson administration considered implementing a cap and trade scheme to mitigate emissions in the state of New Mexico. The first hearing was before Richardson left office, and I testified about climate science as an expert witness for the state. Governor Martinez, this happened during the election campaign, and Governor Martinez, one of the things she promised to do was get rid of the cap and trade scheme that the Environmental Improvement Board recommended, and she made good on her promise. So as soon as she took office, literally within days, remember she was inaugurated on January 1st, by January 5th, she had dismissed all the members of the Environmental Improvement Board and replaced them with her own appointees, who immediately held another hearing, and I got to give the same testimony that I'd given a few months before, now on the opposite side. We can argue about whether that was a good policy or not. There's an argument to be had there, but what got me upset was this quote. Unfortunately, the majority of EIB members, said newly elected and newly seated Governor Martinez, have made it clear that they are more interested in advancing political ideology than implementing common sense policies. As long as we are translating any attempt to mitigate greenhouse gases as political ideology, we're in trouble. We're in big trouble until we can get past that. Enough said. And then, you know, we're almost done, and I hadn't mentioned him. We need to re-engage the international community. There's no way to deal with greenhouse gas emissions as a state or as a country. It has to be done internationally. We have the means to do it. As Peter Fawcett mentioned, there was an agreement that came up in Paris and was negotiated a few years ago. And our president last year announced that the U.S. had no interest in participating, despite the fact that the commitments that the U.S. made were actually voluntary. So once again, we're retreating from even the first step in engaging the international community in doing something, anything, about mitigating greenhouse gas emissions. I have to say, I think it's crazy. And without choosing a particular policy, the fact that we are doing nothing and we're proud and blatantly doing nothing about it is just counterproductive. Now, the good news is, I think this is noise. And it may be disturbing and not very constructive noise, but it's noise nevertheless. And one of the advantages of getting old is that you kind of recognize, I think, noise when you see it. And I don't think we're going to be stuck with this kind of counterproductive leadership for too long, in my personal opinion. We're supposed to end these talks with something positive, right? All the people, and so here's something positive. This was from the New York Times earlier this week. Clean energy is surging, but not fast enough to solve global warming. Well, that's silly. We're not trying to solve global warming. We're just trying to limit it. Nevertheless, once you get past the headline and the pedantic objections that guys like me come up with, right? The whole point of this was to say that renewables are on the very rapid upswing. And I think that's going to continue. I think it's inevitable. This picture could have been taken in New Mexico, but in fact it was taken in China. That's the uncertainty for us. Will we in New Mexico be among the leaders? Will we get ahead of the curve here and make this happen locally and move into the 21st century as part of the transition to renewables? Or will we continue to just say, no, never, we resist, forget it? That's a role that we need to choose, and that's where we stand right now in New Mexico. Okay, enough of that, right? I want to thank you again. I'm just unbelievably honored that to get this award and to have people like you choose to share an hour of your time listening to me rant. I need to thank some people. First, all of you at UNM, right, for allowing me to have a job where I define my own research, I define my own classes, I do whatever I want. It's just amazing, and I am blessed to be here. The citizens pay us, and I've met with quite a few of them, and they want us to succeed as a university. They support us. We complain all the time. We'll continue to complain, but we are in a blessed place here at this university, and we should appreciate the society that supports us. Journalists, I couldn't engage the community without help and support from a broad range of journalists. I meet with them all the time, locally, regionally, nationally. Journalists have a tough job to do. They do it without getting much credit, and I am honored that to interact with journalists who are both interested in what I have to say and report it faithfully. It's really an honor to interact with folks like that, and it gives me a megaphone that is so much bigger than anything I would have without their help. The funding agencies, right? I've been supported continuously by somebody or another ever since I've been here. We are lucky to live in a society wealthy enough that guys like me can apply for funds to keep our research enterprise going. It is a privilege to have taxpayer support on that level. And finally, students. Right? I learn more from students than you ever learned from me, and I really mean it. UNM students are a never-ending joy to interact with. They are the principal reason I just have a spring in my step whenever I come into my office, because I get to hang out with wonderful students, and I thank those of you who are here. It's really fun. And my family puts up with me. All those trips to give talks in Las Cruces and Taos, and they keep me from just spending all my time holed up at my desk thinking about climate change problems. So thank you, thank you, thank you. I'm very grateful, and I hope we have some time for questions. Right? Marianne.
Hi Dave, thank you so much for the talk, it was really wonderful. I know you are not into prescriptions, but we have a new governor. And if you were to advise our new governor on, say, 3 or 4 things she might do right away to address either the social inequities about climate change or policy, I'd really like to hear what you think.
I guess the first thing I would say, the most immediate thing we need to do is have a much greater overt recognition that the climate is changing in ways that affect state policies. And we have to adapt to a changing climate. We have to have a state government that recognizes that and builds it into its planning, particularly with respect to water resources. So in a time when water resources are growing scarcer, we've got to recognize that, and we've got to stop making commitments for future water resources allocations that ignore the fact that it's likely we're going to have less water around. And so if there's any single policy matter that I think affects the state here locally, it's water management. Now that's easier said than done, right? We have, the old saying is we have, how does it go? 21st century climate base and 20th century infrastructure for water and 19th century water laws. And so reconciling 21st century climate with existing laws and water allocations is not easy. But it's time to face reality and move in that direction. And then I would, I don't know how to deal with what I view as the profound socioeconomic challenges associated with a really serious transition to renewables. So if I had some quick and easy policy in mind to make that happen, I'd be happy to recommend it. But I don't know how to do it. But we better start thinking about that really fast. Because like it or not, I think the movement to renewables is already happening and is simply going to accelerate no matter what noise we hear out of the federal government. And so we need, as a state, we need to think about revenue streams. We need to think about the northwest and southeastern parts of the state that are really vulnerable if we do seriously move away from fossil fuel-based energy economy. And let's get started on that. That's not really a concrete policy, but it's just got to happen. Yeah. Oh, okay. Oh, I guess I'm.
Yeah.
Great.
So this is also about water. So you mentioned the case with Elephant Butte, and Lake Powell and Lake Mead are also down a lot, and the use is increasing all the time. We have to change something, but I don't know what do we do with these big reservoirs? Do we just take them apart? Or?
We need to think about different ways to store water, I think. And again, nothing I'm saying here, it's not like I have these ideas and nobody's ever thought about them before. We just need to move forward with implementing different water strategies as best we can. But storing our water in big reservoirs far downstream where evaporation rates are really high and water losses are correspondingly high, it's a century-old water storage solution that just isn't optimal, to put it mildly, in the current climate. So to the extent that we can change water policy in terms of interstate stream compacts and allocation compacts to allow us to do what we can to store water farther upstream or under the ground, we should do it. But that's, again, it's easy for a climate guy to just say that, let's just do it. How you actually implement that is going to require a lot of careful thought. And I am concerned that we don't put that careful thought into how we're going to make it work, because we're too busy arguing over whether climate change is a hoax or not. And so that's a tricky one. But there are water storage techniques. People in this building in the civil engineering department are working hard on that. And we need to move forward with different strategies other than hoping that we can fill up Elephant Butte anytime soon.
Professor Gutzler, my name is Jonathan Aber. I'm a school engineer in Kosniak, and I really appreciate your talk, and I appreciate you coming to share your years of knowledge and expertise on the matter. So I have a couple of questions, and I'm coming from a perspective of, so I've served as an expert witness for the California Energy Commission on energy efficiency policy. I've worked for Natural Resources Canada and PG&E, and I said energy systems and energy engineering at Colorado School of Mines. And so when you bring up hard problems that you expect the engineers to solve and think about for a long time to come up with solutions that will move us away from the current state of energy production, it's like someone like myself who studied and done the calculations, I mean, I can say, and I put my professional reputation on it, it's not possible to just displace the energy supply with energy from the sun or from ocean currents or from wind. But there are solutions that do have potential but are opposed by environmental policy groups such as nuclear power generation. And so I guess my question to you is, how can you, as an advocate, adopt a position of like economic policy that's founded on a kind of like a approach where you come in with a solution as opposed to, I don't know how to fix it. I feel like that would be way easier than to convince someone like myself who's done the calculations and studied it to believe that what you're doing isn't just a call for a transfer of wealth. You know what I mean? I mean, one more small point. If the government could direct the whole state of the economy towards a better optimum energy policy, then it would have already. But rather what happened is the free market kind of determined what the most efficient way of generating energy. But to your point earlier, what we've missed in policy, and what I totally agree with you, is there is a malappropriation of the cost of certain things like pollution or other things like that. And that, I feel like, you can definitely win over persons like myself. So how, again, to reiterate, how can a person like yourself take the advocacy and then instead of just saying it's a hard problem, solve it, how can you guys adjust your proposition with a qualifying solution?
Okay, there was a lot there. What I would say as a climate scientist, not as an energy specialist, is that my job is to point out that if we continue on the path that we're on, that some really dramatic, bad things are likely to happen with the climate system. So we end up with a trade-off between putting serious resources into an energy transformation or paying even more downstream in terms of environmental degradation, et cetera, you know, forest burning, big hurricanes, et cetera, et cetera. I make no bones about the fact that I don't have a total transformation strategy on a platter to hand to anybody. So, if we back up a little bit beyond that, if you're asking, am I blanket opposed to nuclear power as part of a potential solution, I would say, for me personally, the answer is no. But there are problems there too that require technical fixes, as we have seen. So part of the nuclear power problem is that old guys like me remember when it was sold as energy too cheap to meter, right? So it was oversold. Bad things happen in places where plants were not made well, as in Chernobyl, or when really unexpected things happen, like a big storm and a tsunami in Fukushima. Those are engineering challenges, right? And so I think there is a place for discussing discussing nuclear power as part of an energy portfolio, my personal opinion. Really, as far as I can take it with any expertise, is once again to reiterate, if we do nothing, we've got serious problems. So we better rely on our friends in the engineering community who can develop these solutions and support them to make it happen. You are entirely correct. I think we're agreeing with each other that part of the problem is that right now nobody pays for climate change. That's a free cost. It's a cost that's not paid for when we generate fossil fuel-based energy. But and that's a market failure. So we have a problem with free market solutions in the sense that there are external costs that simply are not folded into the cost at all. That is another policy fix. But once again, we saw in the last election in the state of Washington where they actually proposed some sort of carbon tax that it didn't pass. So we have a political problem once again to impose a cost that is real but is not being paid by anybody, and that would help maybe move the market in the right direction. So I'm rambling a little bit. Are we sort of getting on the right track?
I hear you. The buy-in, you keep going back to the buy-in. So I would suggest to those looking to win over people that might be considered quote-unquote skeptics, the idea is to get the buy-in by proposing a solution that is balanced with what might appear as compromise, but I believe you can achieve your goals by getting a coalition that's quote unquote balanced across the aisles, but you have to emphasize something that is solution based as opposed to demonizing your enemy. You know, like the governor, Jerry Brown, basically got on the news and said that what happened at the campfire or Paradise Fire in California was because of climate deniers. You only strengthen your opposition when you call those who quote unquote are in the other camp, that kind of stuff. That's what I'm trying to get at, is come with a solution. It's really hard to argue with engineered solution. It's easy to argue policy.
Thanks, Dr. Gatzler, specifically for the talk as well as entertaining such difficult questions. I would like to know if you have any perspective on what would happen to El Paso if the technology that we have today remains on the same level. Would it be habitable? And I have a second question, if I may. First of all, I want to give a big shout out to all the lawyers in the room.
Yeah, some of my best friends are lawyers. Yeah, right.
Yeah, we all need it, right? At some point. But how can lawyers and maybe even business and economist minds help deal with the political problem? Thank you.
Okay, I think I heard two questions.
That's right.
So in terms of El Paso, we can play the same game with El Paso that I played with Albuquerque, right? And so if you want, we can say, what is El Paso going to look like? And maybe we look farther south. I haven't done this quantitatively, but let's say it's going to look like the city of Chihuahua, which is a fine city. It's got wonderful architecture, some good food. People live there, right? So it'll just get warmer. And so we're not saying that the planet will burn up, but climate zones will march poleward. Places that are accustomed and infrastructure that was built to accommodate a specific climate is not going to be appropriate anymore because it's going to be warmer. That's a different thing than saying that nobody could live there. So that's what I would say about El Paso. What can lawyers do to help the political situation? I'm a humble climate scientist. I don't know. We live in a turbulent political time. We've been through times like this in the past. I think it'll calm down one way or another. In the not too distant future, that's my optimistic hope. And so as citizens, we just move forward and try to play a constructive role in society. And I am reasonably optimistic that times of turbulence will calm down. I don't know how else to answer your question. Sorry about that.
That's good.
Yeah. Okay.
So now it's the short person's battle with the mic. So it's really, my name is Monica Kowal. I'm the Director of Community Engagement Initiatives. And 4 years ago when we established this award for Community Engaged Scholarship, I never imagined the breadth and the scope of the awardees and the work that they do and the involvement that they have and the engagement that they have with local, global communities, nor would I imagine the amount of, or the number of applicants that we would get for the award as time has gone on. And I just think that Dr. Gutzler's work is really exemplary in its way, in diversifying at least my way of thinking about what this award has become and just the research that we've conducted here at UNM that makes meaning. It's also really challenging to write closing comments after a robust discussion like this, because you never know really how it's going to go. So I'm just going to ignore the comments that I wrote, and I just want to say one thing. Yesterday, during the Grand Challenges launch, I was sitting at a table with 2 architects, a computer scientist, an engineer, a sociologist, The economist got up and left the table. He must have been intimidated by us. But and my question, growing up, I'm like Rich, I grew up in northern New Mexico. My question, and I'm not a climate scientist, I have no, kind of STEM background at all, but my question was, how do we diversify the revenue of the state of New Mexico to be less reliant on extractables like oil and gas and focus on alternative energies? The surprising thing is that 3 or 4 of the people at my table, architects and computer scientists, wrote very similar questions. And so I got dibs on you to be on my Grand Challenges team. That's all I want to say. And I need a lawyer and an economist, and maybe you in the back too. I think you'd feel really good. So, but I think that the support of the Grand Challenges Initiative, the work that Dr. Gutzler and other community engaged scholars have done on this campus is just an example of how impactful the research and the engagement that we do at the University of New Mexico just really makes such a huge difference in for the people of our state. And I just want to thank the Office of the Vice President for Research. I want to thank Academic Affairs. I want to thank President Stokes for backing the Grand Challenges Initiative and for sustaining this award, because I think it's important to really think differently about how our research, teaching, and service makes a difference beyond just an academic degree, a higher education degree. So I want to thank all of you. And without further ado, I get to pass it off to Gabrielle, who gets to give you your award. Thank you.
Thank you very much, Dr. Cole, and thanks very much, Professor Gutzler, for an intriguing, fascinating lecture. I think there was lots of lessons about hard realities that we're going to face, not only in the climate, but also with regards to societal changes, economic changes coming up. Even hard realities about sponsored research you touched on, right? The fact of the matter is that, I guess to counter your point a little bit, if you didn't have the research funding, you probably wouldn't have much interesting to say. So, it's the.
I didn't hand the funding back.
It's something that we have to live with in our society, and I wish that we all could do what we wanted without writing proposals. I think it's a means to an end at this point. I think that was really a great lecture. Thank you very much. I'd like to offer my thanks to other folks who made this event possible, and especially members of the Faculty Senate's Research Policy Committee. They do the tough job of recruiting applicants and screening applicants and making tough choices, and there are a lot of very active people on our campus doing community engaged research. And it's not an easy task, but they did a fine job, and I very much appreciate that. I'd also like to thank the folks in my office who do the logistics for the event and who arrange for the award and the various aspects of the award that go along with it. So with that, I'd like to invite Dave up here to receive the award, which I'm told is in here somewhere. And I think we're supposed to pose for pictures or something. And Monica, if you would please join us as well. This way? Okay. You could-
Turn it into a selfie.
Why don't you hold it there and I'll- All right.
Thank you.
So, thank you all very much for attending tonight. We have refreshments in the STAM Commons, which is just down the hall here. Please join us and to continue to celebrate the life works of Dave Gutzler. Yes? Would you like me to read it or him to read it? Sure. Okay. So this is the Community Engaged Research Lectureship, and it's presented to David S. Gutzler for his outstanding achievement in hydrologic and climate research that embodies UNM's commitment to community engagement and contributions which impact the relationship between the university and the larger community for the mutually beneficial exchange of knowledge and resources. Gabriel P. Lopez, Vice President for Research, November 15th, 2018.